Guys, we're going to start into our next unit. So we are starting with learning target 10A, which for us will be the parabola and the circle. And we're going to start today talking about the circle. So a circle is the set of all points in a plane that are a distance r from a given point called the center of a circle. We call the distance r the radius. So over here I have a circle drawn, and the center of that circle, let's mark with a dot if I can center this guy. So I have the center of the circle, and then the distance r is the radius that comes out from this. So right there is my center. Whoop. And then this distance r is my straight line, which is my radius from there. And the points on the circle are all the points out here on the outer loop that are the same distance r from the center of the circle. Now, since we're in an algebra class, we're going to focus more on what is happening on a graph for this guy and what is happening in the standard form of our equation. As we talked about yesterday, none of the graphs that we look at in this unit are going to be functions unless we have a parabola that is facing either up or facing down. But the majority of the graphs we're looking at are going to actually be relations now, not functions, because they won't pass the vertical line test when we draw them on a coordinate plane. So let's dive into the standard form of a circle. So the standard form of an equation of a circle with center at h comma k and radius r is the following. It is x minus h squared plus the quantity y minus k squared equals our radius squared. And where this is coming from is similar to the transformations that we have been doing all year. So as we look at this, h comma k is our center, and as we shift around our circle, our x coordinate and our y coordinate will shift according to that center that we have. The first set of examples we're going to look at is going to be to write an equation for the circle given the center and given the radius. So our end goal will be to have an equation that looks similar to this, but I'm going to want to fill in what is my center and what is my radius. For our first example, our center is going to be at -4, 3, and our radius is going to be 4. So my h value then is going to be the -4, and my k value, if I write that as a coordinate pair, would be the 3. My radius right here is going to be 4. So my r value is going to be 4, and I'm going to use my standard form up here to substitute into the correct places. So I get x minus, instead of h now, I get -4. The entire thing squared, plus y minus, well in place of k, I'm going to put 3, the entire thing squared, equals our radius, which is 4, and we have to square that term as well. Now this is perfectly correct for an equation of a circle, because we want to simplify stuff a little bit. All I'm going to do is reduce the double negatives that we have here. So I end up with x plus 4 whole quantity squared plus y minus 3, the entire quantity squared, equals, I'm going to write that as 16 instead of 4 squared. That piece right there is our final answer for our equation of our circle. Let's do this for one more example, and then I'm going to have you guys pause the video and try the third one on your own. So for our next guy, our center is going to be 5, -2. Our h value is going to be 5, and our k value will be -2, and our radius is going to be 8. So if I write this out, we're going to get x minus 5 whole quantity squared plus y minus -2 squared, need one more parenthesis there, equals our radius, which is 8 squared. Just like before, you could leave it like this, but I'm going to simplify it down to make it look a little bit cleaner. So we get x minus 5 squared plus the quantity y plus 2 squared equals 64. So those are two kind of separate examples, well they are two separate examples, looking at if I have a center where maybe I did shift to the left, shift to the right, shift up or down depending on what's happening, I do end up with my equation of my circle based off of my standard form up here, using my h value and my k value to sub in as my center and using our radius value. I'm going to have you guys go ahead and pause the video right here, and why don't you try C on your own, and then we will check it. Okay, let's check C now. So our center is at 0, -7. So my h value is 0, my k value is -7. Oop, hold on, technical difficulties happening. Let's erase that little mess that got made. So our k value, as I was saying, is -7, and our radius here is going to be 3. So if we write this out, we'll get x minus 0 now squared plus y minus -7 squared, one more parenthesis, equals our radius squared. Now if I'm going to clean this up, there's no reason to write x minus 0, and because I only have x inside the parentheses, I can actually drop them. So I get x squared plus y plus 7 squared equals 3 squared, which is 9. And there's our last example for given a center, given a radius, write the equation of a circle. Okay, let's look at a slightly different type of example here. So before we move on to the graph, what if we kind of rephrase the question here? So question 2 says, what is an equation for the translation of the circle x squared plus y squared equals 9 by 2 units right and 3 units down? Well, we're doing ultimately the same thing we did before. The question is not just directly laid out this time. So the circle that they're giving us, if I think about the given circle right here, it has a center that we can find. So the center on this circle is actually going to be 0, 0, because there's nothing added or subtracted inside the squares on both of these. Similar to how on this last example up here, because the h coordinate was at 0, I ended up with just x squared on there. So the circle they're giving us is centered at 0, 0, and then I'm going right 2 units and down 3 units. So if I think about moving this on a graph, my new center then would end up moving based off of where it started. So if I start at 0, 0 and I go 2 units to the right, then I'm going to end up now at 2. And then if I started at 0 for the y coordinate and I go down 3 units, I'm going to end up at -3 for the y coordinate. This will then be our new center, so we can start to write out our equation. So we get x minus 2 squared plus y minus a -3 squared equals, now my radius. When I translate a circle or I shift it around on the graph, the radius isn't changing. So my value over here that it's going to be equal to is going to stay the same because that part's not being shifted at all. I'm just picking up the circle and literally moving it 2 units to the right and 3 units down. Now to clean up our final answer, just like we've been doing in the prior examples, let's just kind of rewrite this in a cleaner format. So we get y plus 3 squared equals our 9 value. Okay. Now let's look at what a graph would end up looking like. So if I go down here, I do have steps for how to graph that we will use once we get to the graph portion. But the first thing I need to find is, well, what's my center and what's my radius? Because if I don't have my center and my radius, I can't actually graph this. I'm not going to get very far. Well, let's go back over here and let's kind of write standard format on the side so that we have it. Remember, standard form was x minus h squared plus y minus k squared equals r squared, and our center out of this is going to be h comma k, and our radius here is going to be equal to just r. So we're going to use this to help us kind of undo the information and find it from the problem that's given. So if I go up here, I have x minus 2. Well, that tells me that my x coordinate of my center is going to be positive 2, because as we notice over here, if I have x minus h, the center is going to be positive h, so the signs are flipping. And then for y plus 3, well, y plus 3 is the same thing as y minus a -3. So that tells me that my y coordinate there of my center is -3. Now to find my radius, I'm going to use the 4 value, but if we look at the general form, that's equal to r squared. So I know that 4 is equal to r squared, so I need to solve this to find r. Now to isolate r, I need to get rid of the square, so I will square root both sides, and I end up with the square root of 4 equals the square root of r squared. Now, as we've talked about all year, because we're applying a square root, we technically do get that plus or minus. And if we reduce that down, I get plus or minus 2 equals r. Well, the radius right here is representing a distance. So anytime I look at a distance, it has to be positive So I don't need to worry about the -2 value because my radius will always be a positive value. So my radius up here is going to be +2. So although we do pick up the plus or minus because we're taking a square root, that is correct to think about. What we're trying to find here is the radius, which is representing a distance here. So I only want to take the positive value since it is a distance. Now that we have that information, we're going to graph this. So my steps over here, the first thing I have is let's plot the center first. So I'm going to go over 2, down 3, and I'm going to plot my center right there. Now that's the point that's in the center of the circle, and all the other points are a distance that is equal to my radius out from there. Well, I could go in any direction I choose, and I could move 2 units, but if I go at a diagonal, I'm not really sure what 2 units looks like on a diagonal, but I do know what 2 units looks like if I go up. So if I start at my center and I go up 2 units, I'd end up right here at 2, -1. Now if I go back to my center and I go down 2 units, I'd end up right there at 2, -5. And if I go back to my center and I go to the right 2 units, I'll end up at 4, -3. And if I go back to my center and go to the right, or to the left, 2 units, I'd end up at 0, -3. Now these 4 points on the outside here are going to actually be on my circle. Now to connect these, remember I'm trying to sketch it to be a circle, so I'm not going to draw straight lines in between them because that would give me a diamond shape. I want to sketch it and get the circle shape. Now, not the best with this drawing tool here, so I'm going to try my best. So I sketch around it and I get that circle. Now don't worry if your circles look a little too oval. What we're going to be paying attention to is, are our points on that circle correct? And I am going to ask you guys to label these points. So this point over here I had was 4, -3. This point up at the top was 2, -1. The point down here is 2, -5. And our point on the left is 0, -3. And then our center point that we started with to move from to get all 4 points, if you notice, is not actually connected to the circle, and it's not supposed to be. So the circle is based off of where the center is at, but none of these points are going to connect to the center. They're all just a distance r from the center of that circle. Okay, I'm going to have you guys pause the video again, and why don't you try example B and see what you guys end up getting. Okay, let's check on our example B. So if I'm using my standard form here, because I have x plus 1, my center is going to be at -1 because we have the x minus the -1 there. Then for my y coordinate, because I have y minus 3, I'm going to end up with a +3 for my y component. Now for my radius, I need to take the 25, that's going to be equal to my radius squared. So that tells me that my radius is going to end up being +5. And just like before, I don't need to worry about the negative answer since my radius is representing a distance. I want the positive value from there. Now let's go to graph it. I got to plot my center first, so I'm going to -1, +3 up here. Now from here, I'm going to move 5 units up, 5 units down, 5 units right, and 5 units left. So let's start by going up 5. 1, 2. Then I can go down 5. Plot that point. Go back to the center and go right 5. And left 5. Now, since this radius is bigger, we can tell the circle here is more spaced out because they're all a further distance from our center here. I'm going to do my best to sketch these together and see what I get as I curve it around. Looks a little oblong, but that's okay. I do want to label my 4 points on the outside, so let's start with the point down here. The point down here we have is going to be -1, -2. Our point on the right side is at 4, 3. Our point at the top is at -1, 8. And our point on the left side is at -6, +3. And we have our graph of our circle there. That's going to be everything that we're going to be focusing on in terms of the circle. So the two big goals that we're doing is, given the center and the radius, can you write the equation and graph maybe after that? The second one would be, given the equation, can you find the center and the radius and then graph that? Okay, let's scroll down and look at our next part of this learning target. We're going to focus back on the parabola, which we spent a lot of time last semester talking about the parabola when we did quadratic functions. And instead of redoing all of that stuff, we're going to focus in on some more vocabulary that can actually go into play with this and talk about, more importantly, well, what happens if I have a parabola that opens up on its side and is no longer a function now? So, formal definition of a parabola is the set of all points in a plane that are the same distance from a fixed line, called the directrix, and a fixed point not on the line, called the focus of the parabola. So that definition can be really confusing if you don't have a picture. So I kind of want to look at this picture that we have in our up-down first type. So what's happening here is my directrix, in this case, is going to be a horizontal line because the parabola is either opening up or down. The parabola will not intersect the directrix. The focus is a point that is inside the direction that the parabola is opening. So because my parabola is opening upwards in this picture, my focus would be inside. Now, what they mean by the same distance, because this is a very geometrical definition that we have here. So if I pick any point on here, so I'm going to pick this point right up here on my parabola. What that means is that if this is drawn proportionally, which, because I hand sketched it, it's not going to be perfect and proportional, it means that the distance between this point and the directrix down there, if that was a straight line, is going to be equal to the distance between this point and the focus over here. So these two distances here are both going to be equal that we would have. Now this is not drawn perfectly to scale for us, so it's not going to look exactly perfect, but if I had a nice computer model of it, I would see, or on my calculator, I would see that the distance between any point on the parabola to the focus is equal to that same distance from that same point on the parabola down to the directrix, and that's why it's there. We go ahead and erase those so that we can kind of label more of what's going on with this graph. So we're going to look at two types. We're going to look at the type that opens up or the type that opens down. That's what we spent last semester on. We've seen these equations before, and they were of the form y equals x squared. Now, as we talked about yesterday in class, I'm not going to shift these at all off of the origin. So for all of these, my vertex is going to stay at 0, 0. So my vertex down here, if I want to label that, is going to be at 0, 0. And because we're not shifting our vertex, I'm only going to have a stretch or compress factor. And that stretch or compress factor, I'm going to write now as 1 over 4c times the quantity x squared. So this 1 over 4c is my quote-unquote stretch or compress that we talked about a lot last semester with transformations. But I'm writing it in this form for a reason that you're going to see in a second as we define what the focus and the directrix is. So my vertex is staying at 0, 0 for all of these. My focus is the point up here. It's on the y-axis, so it's actually a y-intercept. So it's 0, something. And the y value there is actually c, where c is this number in this 1 over 4c coefficient. So my focus then for this guy is 0, c. My directrix down here is a horizontal line, so it has to be of the form y equals, and it's actually y equals negative c. I'm going to explain why that is in a second. So that definition that we had said that any point on the parabola is the same distance to the focus as it is the same distance to the directrix. Well, if I take the vertex, which is at 0, 0, the distance up to the focus here, this distance that we have right there is actually c, because I moved up to the coordinate pair 0, c, which means that this distance should also be c if I go down, which is why that is intersecting at y equals negative c down here. So the focus and the directrix are actually the same number, they're just opposite signs of each other. So if one is up at a positive number, the other guy is at a negative, and then if I flip this graph and I flip it upside down, and I look at a parabola that is now facing downwards, now my focus is then going to be inside, so that right there would be my focus, and my directrix would actually be the line, a horizontal line still, but it would be above the graph if I end up flipping it upside down. This will be everything that we'll need to know to be able to solve these problems. So you really want to make sure that you've memorized this 1/4c concept, and pay close attention to the fact that the focus here is a y-intercept. The directrix is a horizontal line, so it's y equals, and that the equation is also y equals x squared. That's all going hand in hand because it is a parabola that is opening up or down. The next thing we're going to look at is what happens if it opens right or left, and we're going to notice that we get similar things, but they all kind of flip in terms of my x and my y. So if we scroll down to a parabola that opens right or left, I still have the same type of graph. So this one's opening to the right, the focus is inside, the directrix is on the opposite side of it, and I still have my vertex right here that's going to be at 0, 0. So I'm going to add my vertex to it. Now, because this is opening to the right or the left, instead of it being y equals, this is going to be x equals. So I'm going to get x equals 1/4c again, and now that's going to be times y squared since it's opening to its sides. My focus here is now on the x-axis, so it's an x-intercept that's at c, 0. So I have an x-intercept now. And my directrix is a vertical line, so this is x equals -c. Because if this guy's over here at +c, this value right there is -c. And it is a vertical line. So if we notice, we have a lot going hand in hand here. So let's switch to a highlighter to kind of make sure we're tapping into what's happening here. Notice when I have x equals, I get an x-intercept and I get x equals in my directrix because it's a vertical line. All of that happens anytime this graph opens to the right or to the left. Now if I flip-flop that and I go back to what's happening up or down, when I have y equals, it's my up or down parabola like we're used to seeing. I have my focus that is now a y-intercept, and my directrix is y equals because it's a horizontal line that we have. Now, just to give you an idea of what this graph would look like over here if I open it to the left, let's make that a better axis. Well, there we go. So if I open it over here to the left and I draw my axes that we have, the graph now is going to open to the left and it's going to sketch from here. We're going to have a directrix that's still a vertical line that's happening over here, and my focus would be inside this parabola right there that we have still with our vertex at 0, 0. Okay, let's move on to some examples so that we can see these in action. So we're going to start with finding the equation given one piece of information. So the example says, what is an equation of the parabola with the vertex at the origin? So the vertex is at 0, 0, and our focus is at 0, 2. Well, it doesn't seem like a lot of information, but let's kind of sketch what a graph of this would look like just to have an idea. So if I graph 0, 2, I'm up here on the y-axis. What that tells me then is because this is a y-intercept, that means that I must be of the form y equals 1/4c times x squared. And my goal to figure out this equation is, well, if I know what c is, I can sub it in, simplify the coefficient, and get my final answer. I also know that this graph is opening up because the focus is on the positive y-axis, so the parabola would have to open up towards it. Now our focus is always at 0, c, which tells me that my c value is equal to 2, since that's the value for my focus. Using this piece of information that c is 2, let's sub it in, and I get y equals 1/4 times 2 times x squared. So my final answer here would be y equals 1/8 times x squared, and that will be our final answer that we get then. Why don't you guys pause the video right now and try the next one if we have the focus at -5, 0. Okay, let's go ahead and check this guy. So I'm going to graph it again because it gives us a nice visual of what's happening and what axes I'm on. So if I graph -5, 0, I'm over here on the y-axis, or I'm sorry, on the x-axis. So this is now actually an x-intercept, which tells me that I'm going to be of the form x equals 1 over 4c times y squared. So again, I just need to know what that c value is, and then I'd have my entire equation. I also know that this is going to open to the left because my graph has to open towards my focus. So this is opening to the left. And the last thing I want to take advantage of is the relationship that the focus has. Well, the focus is always the c value, so that tells me that c is -5. I can use that to sub in, and I get x equals 1 over 4 times -5 times y squared. So my final answer would be x equals -1 over 20 y squared. And that piece then would be our final answer for this guy. Now both of these were similar because they gave us the focus, which is going to be my c value always. So that was really kind of nice and straightforward to sub in what is the c value into my equation. The only tricky part I have to think about is, well, is the parabola opening up or down? So is it y equals, or is it opening right or left, which would make it x equals? And the easiest way to figure that out, I think, is if I put it on a graph so I can visually see what's happening. When I graph both of the focuses on here, my parabola has to open towards the focus. That is the key here, is that the parabola opens towards the focus, which tells you if it's opening up or if it's opening, in this case, to the left. Okay, what if they gave us now the directrix instead? So they're giving us the opposite piece of information. So I'm still going to do the same thing. I'm going to draw a little graph to get an idea. So the directrix here is at x equals -4. Well, x equals -4 is going to be a vertical line that goes through -4. So if I go over here, 1, 2, 3, -4, then my directrix is that line right there. Now my parabola has its vertex at 0, 0. And opposite what the focus does is my graph always opens towards the focus. So if the directrix is on the left side, it needs to open in the opposite direction. So this will open to the right, and I'll get that shape of a parabola right there. What this tells me then is I'm still looking at the form x equals 1 over 4c times y squared. And just like before, I need to figure out what that c value is. Well, the focus is what c is equal to, but if I scroll back up and you guys look back in your notes, when I'm looking at a parabola, the directrix is always -c. So I can't take that number exactly. I get the negative of that. So what that tells me then is that -c is equal to the value of the directrix, so -4 in this case. So I can divide through by -1, and I can find out that c is equal to +4, which should make some sense because on my graph then, my focus should be inside my parabola, which would be over here at +4, versus the directrix over here at -4. Let's add that in there. I can sub that in now that I have my c value, and I get x equals 1 over 4 times 4 y squared, so x equals 1 over 16 times y squared. And there's our final answer for that guy. Why don't you guys pause the video again and try our last example here that we have for finding the equation. Okay, I'm going to go ahead and draw it. So I have a directrix that's at y equals 3. This is going to be a horizontal line now because it's y equals. So I'm going to go up on the y-axis to 3, and I get this directrix right here that I end up with. Because the parabola always opens opposite the directrix, that tells me that if my vertex is at 0, 0, instead of opening up, I'm going to open down so that I'm going away from the directrix. So my final equation then is going to be of the form y equals, since it's opening in this case down, so I get 1 over 4c times x squared. From here, the last thing I need to do is find my c value. So because we're given the directrix, I know that -c is equal to my directrix value, which is +3. So in this case, c is actually -3, and we can sub that guy in. So our final answer ends up being y equals -1/12 times x squared. Okay, let's look at our last type of example, and we're going to do the opposite. So we're going to find the vertex, the focus, and the directrix given the equation now. So what we want to pay attention to is it x equals or is it y equals? Well, in this first equation, because it's x equals, that's telling me that this is opening to the right or to the left, and we'll find out a little bit more as we keep going. Now, I'm going to get rid of the vertex and answer that right now. So the vertex for this is always going to be at 0, 0 because I'm not shifting them off of the vertex at 0, 0. Because this is going to be x equals, it's right or left, so that tells me that my focus then is always going to be some number, comma 0, because it needs to be an x-intercept in this case, and that my directrix is going to be x equals some value. Now what's left to do is figure out, well, what is this value? That's coming from our c values. So let's look at a general form of this. If I have x equals 1 over 4c y squared, in general, I'm particularly looking at, well, the equation x equals 2 times y squared. Well, let's think about this. Both of these are going to be equal to x, so I can actually set these two guys equal to each other and get 1 over 4c y squared equals 2 times y squared. And the reason I can do it is because they're both equal to x, so using substitution, I can set those two guys equal to each other. Now from here to solve this, my goal is to figure out what c is. Well, I have something times y squared equals something else times y squared. Guess what? The y squareds are going to cancel each other out because I have an equal amount on both sides, and I'm really just looking at what are the coefficients equal to. Because my coefficient over here was 2, my coefficient in general is 1 over 4c, those two guys must be equal then. To solve this, I'm going to cross multiply. So I get 1 equals 2 times 4c. If I move over here to the right, we get 1 equals 8c. So I end up with 1/8 equals my c value then. This piece right there is going to be our focus. So I get 1 over 8 is my focus, and my directrix is the opposite sign of that, so it will be negative 1 over 8. Now this way can be a little bit trickier because you've got to figure out and pull the pieces out instead of being directly given the value for c. But let's walk through this one more time. So ultimately what I'm doing is setting whatever my coefficient here is on my y squared equal to the coefficient that I get in general, which is the 1 over 4c. Now this coefficient, which I'm going to highlight in 2, is always going to be equal to my general coefficient, which is the 1 over 4c. So this is where I'm getting this equality statement right here then. The reason I can do this is because they're both equal to the coefficient on the y squared. So by setting them equal, the y squareds are ultimately canceling each other out, and we just get to set the two coefficients equal to each other, and we can solve by cross multiplying. Why don't you guys pause the video again and try the next example. Okay, we've got 2 more. Let's look at the first guy here. Well, right off the bat, I can answer the question of the vertex. The vertex is at 0, 0. Well, this one is now of the form y equals, so this is opening up or down. More importantly, what that tells me then is that my focus is a y-intercept now. So it's going to be at 0, something, and my directrix is a horizontal line, so it's y equals some number. We're going to do the same thing we did before. So in general, I have y equals 1 over 4c times x squared. And because this specific one is y equals negative 1/2 x squared, because they're both equal to y, I can set these two guys equal to each other. So I get 1 over 4c times x squared equals negative 1/2 times x squared. Again, the x squareds are canceling each other out, and I just want to focus in on, well, what is the scalar piece that I'm getting here? So because this will be true for all x values, I need to figure out what c value makes this true. So 1 over 4c has to equal negative 1/2. Now from here, I'm going to do some cross multiplying again. So I get 1 times 2. So I get 2 equals my negative 4c by going 4c times negative 1. Now to solve this guy, if I divide through, I end up with c being equal to 2 over negative 4, or C is equal to negative 1/2. What that tells me then is that my focus is always at 0 comma negative C, 0 comma C, so I end up with 0 comma negative 1/2, and that my directrix is at the opposite of this, so it will be at negative C, so I get negative 1/2, or positive 1/2 in this case. And now let's try our last example that we have. So we have another example down here that's back to being x equals, so I know that this is opening to the right or to the left. Like always, our vertex is at 0 comma 0, and our focus is now going to go back to being an x-intercept, since this was x equals, so I'm going to have some number comma 0, and my directrix is going to be back at x equals some value from there. Now I want to set these two guys equal to each other. So in general, I have that 1 over 4cy squared. Specifically for this example, I have the 3/5 y squared. So let's set these guys equal. Since they're both equal to x, then that tells me that 1 over 4cy squared is equal to 3/5 times y squared. Since this has to hold true for all values of y, and I have a y squared on each side, I can cancel those guys out. Say that 1 over 4c is equal to 3/5. I'm going to go through our cross multiplying like we've been doing. So I get 1 times 5, which is 5, is going to be equal to 4c times 3, which will be 12c. Solving this guy, c is going to be equal to 5 over 12 then. What that tells me is that in my focus is my c value, so I get to 7 5 over 12 up there for my focus, and my directrix will be at negative c, so it will be at negative 5 over 12 then for this problem. This is the end of this learning target for you guys, so we are done. This will be everything that we do talking about the parabola or the circle, and the next step for you guys is to check and get your exit ticket done, and you guys will be good to go in this